Welcome to Nordeus. With 6,000 square meters and 52 flexible offices, this building is a home to 170 employees. Anyway, you know where to find us. See ya!
Hello again. Our next speaker will present a talk titled Comparison Analysis of Facebook's Profit, Amazon's DeepAR Plus, and CNN QR Algorithms for Successful Sales Forecasting Based on Real-World Data. Please welcome Emir, the head of AI and ML department at InfoStudio. Emir, the stream is all yours.
Okay, thank you very much, Mirjana. It's definitely my pleasure to be part of this great event, and thank you to the organizers for the invitation to be invited to be a speaker second years in a row at this great event. Today, as you said, my name is Emir Zunic, and I'm currently head of artificial intelligence and machine learning department at InfoStudio, one of the oldest and one of the most respectable IT company in Bosnia and Herzegovina. And also I am assistant professor at one public university here in Bosnia and Herzegovina and co-founder of one startup company, Edu720. Just before we start with today's presentation, just to recap my presentation from the last year, then we presented several case studies, successful real-world case studies of application of artificial intelligence and machine learning in warehouses, in transport management, in banking and finance, and also is in HR and educational level. Today, I will present our achievements, our results of two scientific papers that we applied on real-world scenarios and real-world problems, and the results that we got are really more than satisfactory. Most of the results that we achieved are recognized around the globe in industry and academic area as well, so I will present it today. Before we start with the concrete theme, just to put attention on, for me, one of the most important part of application of AI and ML in real-world applications. For me, the hardest part of that is to find the, let's say, the appropriate way and the appropriate place, how and where we can apply that. It's important to have that in your mind, and also from the another part, it's important to constantly to talk with the business users because of great implementation and great real-world results. Because of that, let's say it is important that the simplicity of the application is really required for the customers, not for you as an implementators. It's something like it's that comparison. It's something like water supply, something similar to the water supply mechanism, because it is really complex in the background, but it's really easy for the usage by the end users. A little baby can take the glass and take a glass of water. So it's really important to have that conversation with the business users and to find the appropriate way and an appropriate place for the implementation of AI and ML in a real world. So based on that, we analyzed every data, and it's really important to log everything that you can. So maybe that data are not necessary in that time, but later you can analyze that and you can conclude something new. Successful sales forecasting mechanism can have positive effects in many areas of business, and one of the basic aspects is definitely stock optimization. In retail, wholesale, and distribution companies, inventory optimization is one of the key aspects of business. Companies that maintain their stocks at the adequate and appropriate level can save significant amounts of money. And at the same time, their other processes such as warehousing, commissioning, shipping, transportation, etc., are significantly improved. But in practice, there is always a big gap as you can see on this picture, between stock and sales. We decided to analyze deeply those data and aspects in real world. Just to put attention once again, this is important because of real world environment and real world data and the obtained results I will show you today. Before we start with concrete thema, just to explain this problem in more detail, let's use the explain of a company with a turnover of 10 million euros. Let's assume that the average inventory turnover ratio is 10, although many companies are not at that level. Let the profit margin to be, for example, 8%, which is an industry average. And according to the calculation shown in this picture of this slide, the cost for not having time to optimize stock for this company is more than 70% of their profit annually. This is really huge, and you can save that money definitely. This picture presents a slightly different analysis for a company with a lower profit margin that, for example, 5%. The loss is even bigger. It's around 22 or 23%, while a company that has a profit margin of 10% due to inadequate inventory management loses about 60% of profit. It's definitely huge. These pictures show analysis for companies that in practice do not pay enough attention to quality inventory management. So we decided to do one step forward and to do something to optimize the stock and through the sales forecasting. This picture shows the stock status of a typical FMCG product, although it is not a product that has a short shelf life. Very often there are lost sales due to depletion of stock. Also, the stock of this item may be reduced. The dominant cost of this item is lost sales, and definitely in the covered period of more than 1 year, depletion was performed in this scenario is performed 84 times, which represents 21% of the days without the stocks, and that's definitely a problem in a real world. So, based on the above analysis, it is easy to conclude that there is a huge potential in the real environment, which is mostly based on successful methods of sales forecasting. On the other hand, if sales data are observed through history, then it can easily be reasoned that the data is in the so-called time series format. So there are many methods for forecasting based on time series data, and this presentation presents a comparison analysis of a few algorithms that we applied on that data. Data set that is a real world data set from one that we obtained from one of the biggest distribution companies in Bosnia and Herzegovina, and we published that available publicly, and it's available in order to be available to the rest of the researchers, the rest of the industry experts as a new benchmark data to train the models and to try to do something better than we made. We have developed plenty algorithms and methods in this way, such Facebook Profit, Amazon DeepAR, Amazon DeepAR Plus, Amazon CNN QR, then SVM, support vector machines, decision trees, naive Bayes algorithms, fuzzy expert system, auto regression, and with moving average, artificial neural networks. So we have implemented really plenty algorithms and methods in this way, compared obtained results, and the best results definitely shows the Facebook's and Amazon's algorithms. So we decided to analyze those algorithms in more detail. Firstly, we started with the Facebook profit algorithm is because it is really simple to use, and the results are really more than satisfactory, and a module that would be able to forecast sales with reasonably high accuracy, augmented by the module for a highly reliable classification of the product portfolio according to the expected level of the forecastability. Would be of great use for any company operating in the retail history. The proposed model for successful sales forecasting is shown in this picture. The upper part with the number one, label with the number one, in the illustrated model can be represented as offline segment in the whole approach for the purposes of model accuracy and classification, and the second part, labeled with the number two, represent the sub-process of successful sales forecasting. It's really important to analyze the set deeply. And here is one example of our real-world data set, which is structured as a table of records with several main labels, such as item code, date, quantity, and unit price. So based on that data, it's really possible to have a time series data set and to predict the sales based on that data. Several steps were taken during the pre-processing phase to transform a table of records into a convenient form. For example, which is shown in this picture, filtering by date in order to remove irrelevant historical data, confinement of quantities into the same unit, data aggregation in the time domain at the product level, and so on. It's really important to mention here the product portfolio selection, because you have a real world data, and it's really important part and important aspect. Based on the industry experience and discussion with clients in real field, it was concluded that several different criteria can be used to sort product portfolio by relevance. Firstly, the total profit per product over the last year, the total financial turnover, and the total quantity sold per item over the last years. That's the three main aspects in the product portfolio selection. As I mentioned before, we firstly started with the Facebook profit algorithm, and the basic building block on the proposed framework for sales forecasting is definitely that Facebook profit, and it's really easily to use that tool for this and other researches that we have implemented, and it is capable of generating forecasts of reasonable quality at scale. Profit is, as you know, probably an open source software released by Facebook's core data science team, and it is in a procedure developed for forecasting time series data based on an additive model where nonlinear trends are fit with yearly, weekly, and daily seasonality plus holiday aspects and so on. For our purposes, it is empirically concluded that at least 24 months, 2 years of historical data is required for a reliable estimation of trend and seasonal effects. An example of using Facebook Profits tool to forecast the future sales for the product with the sales per month time is shown in this picture for the next 3 months. So we have and the model know the data in this red zone, and we predict the data, predict the sales for the next period in this picture for the next 3 months, which is in the green zone of this picture. Two performance metrics are used for measuring forecasting accuracy, calculating the expected level of forecasting accuracy, and classifying product portfolio accordingly. The relative percentage error and the equation is shown here, and also the mean absolute percentage error, which is shortly called MAPE, for quantifying the overall accuracy. And definitely the MAPE is a good measure because it is used to qualify the overall accuracy of the forecasting framework and calculate the expected level of reliability usable for classifying the product portfolio. So based on that, let's say on the train and the other things that I mentioned, In this research, the backtesting experiment is repeated 12 times with one month step size for items selected for the product portfolio. At each step, a profit model is fitted to the data from the historical data. It's called observation horizon, and it's in this red zone. And monthly sales forecast for the next 3 months. That's a forecasting horizon are compared with the observed sales for the same period in order to calculate percentage error for the monthly and quarterly forecast. Then we execute a level of stability is concluded at the mean absolute percentage error MAPE over repeated backtesting experiments, which is used to quantify the expected level of forecasting reliability. An example of forecasting performed analysis for a single item in the product portfolio is illustrated here in this picture, and also when we move one month backward, it's shown on this picture. So we do that this backtesting 12 times or 12 months in a history. For the analyzed item, which is shown here in this picture, the MAPE is 8%, and the quarterly forecast MAPE is monthly, and the quarterly forecast MAPE for the same item is around 6%, which is really more than satisfactory in the real world, because if you can predict something with accuracy or with the error less than 10%, you have really a good weapon in your hands, definitely. In this data set, total number of 581 items in product portfolio are observed, while 400 of these were active. For example, have non-zero sales are observed at least once over the past year in the data that we analyzed. According to the guidelines proposed and that I mentioned before, items in a product portfolio are ordered by the total financial turnover per product over the last year, and top 200 items are selected with the aim of covering approximately 90% of total financial turnover. It's important here to mention that the important part of the whole process is definitely the product portfolio classification. The first criterion used to classify the product portfolio is based on the observation horizon length and recent sales downtime. So we identified several categories: inactive products, products with observation horizon shorter than 25 months, with the observation horizon shorter than 3 years, and the products with observation horizon at least 3 years long and more. Classification of top 20 products items in the portfolio by this criterion is illustrated here in this picture. As we can see, we have a really close to 60% of items with the history more than 3 years, which is really nice to analyze and to achieve a good results. The second criterion for classifying product portfolio, which can be applied to a subset of products with observation horizon at least 3 years long, is based on the expected level of forecasting accuracy calculated as a mean absolute percentage error for repeated backtesting experiments. So we classify that in several intervals. For example, with the MAPE less than 15%, between 15 and 30%, between 30 and 50%, and more than 50%, and classification of the products with the observation horizon with at least 3 months long history by the criterion both for monthly and the quarterly forecast are illustrated here in this picture, and for the quarterly is presented here. As we can see, we obtain mostly better results on a quarterly forecast because it's easy to forecast something on a longer path in the future. It is important to mention that these approximately 40% of the product portfolio, which can be forecasted with MAPE less than 15% on a quarterly basis, are mostly the best-selling items of the aforementioned retail company. And if we have that in our minds, if we have that unit prices, that is more than 80 and close to 90% of annual share financial in the whole portfolio, which is really important to mention, because if you can predict for the in a financial way, if you can predict for more than 80 or close to 90% of the product portfolio with the error less than 50%, that's really good results. So when we obtained the good results with the only Facebook profit, we decided to do one step forward, and we implemented the same model as before mentioned, but with the other algorithms such as Amazon's DeepAR, DeepAR Plus, and CNN QR algorithms. And we have a voting system which will vote the better algorithms for each input data set as the results. You can find a lot of, let's say, publicly available things about those algorithms, and I will not describe that in the details, because that's everything open source, and you can find that in the literature, definitely more details. But all those algorithms are really new, really prestigious, and give us really good results for the time series forecasting. In our case, now we use another, let's say, another type of error that we analyzed. That's a WAPE, weighted average percentage error, and the metric was chosen in relation to the standard MAPE, as I mentioned before, metric due to occurrence of falsely high results for items where sales are close to zero in certain months. And we split the data in two, let's say, two analyses: items with the long history and items with the short history. In this picture, a visualization of accuracy for the financial importance of the item for the long history is created, and the comparison is given for all three algorithms, with up to 4 points shown for each item on the x-axis. And the red line on this picture represents first order implementation, and represents a visualization of error growth by reducing the importance of the item. The line shows better quality results for profit algorithm for important items, but also a decrease in performance by reducing the importance of items. In this picture, the data from the previous picture is shown in the form of cumulative histogram, and the columns represent monthly and quarterly forecast, and therefore the left histogram primarily shows that on a monthly basis with an error less than 20%, WAPE profit, Facebook's profit can predict about 70%, and other algorithms such as DeepAR, as CNN QR has bigger error on this data set. Similar analyses were performed for items with a shorter history, and due to the specifics of the items and the work of distribution companies, the number of such items is significantly smaller, which is really good in a real world. And given the consistency of the results, the described conclusions were drawn, and here in this case is the Amazon's algorithms are better than the Facebook's profit algorithm in the data set with the shorter history of the time series. Also in this picture, a cumulative histogram for sales prediction is given, and the obtained results confirm significantly better performance of Amazon's algorithms compared to the profit which is better for a long history of data. Also, we did another analysis, COVID-19 analysis as a forecasting challenge, let's say. And one of the important factors of the forecasting process is the ability to solve and cope in unexpected situations, which is definitely COVID-19 crisis. And this picture shows the analysis done in the period 12 months before the COVID-19 and the backtesting analysis for the first 12 months of COVID-19 COVID-19 in the same company in Bosnia and Herzegovina. The performed backtesting analysis on the most popular items showed insignificant changes in the obtained results, which proves that the proposed forecasting model can cope well with unexpected changes, definitely. And analyzing obtained results shown in this picture in more detail, it can be concluded that the forecasting is a bit better, let's say, after the first 12 months of COVID-19, because mostly caused definitely by longer data history for that one year. By using proposed algorithms, in real world company can reduce their stocks from this black level on this picture, black line, to the green level or green line in this picture, with the same level of security and the same level of delivering items to the final customers, which can really save the money and optimize the stock for that company. Briefly, let's say about me. You have my Facebook here, and you are welcome to connect with me through Facebook, and we can definitely discuss more about these algorithms. Also, let's say I want to thank the company Info Studio Sarajevo from Bosnia and Herzegovina for making this research possible through funding and providing access to the necessary data. And what we are doing currently, to conclude, let's say, or what are the next steps? We now try to analyze another algorithms and to apply that on the same data set. And we concluded that the Orbit algorithm, which is an open source algorithm from the Uber, gives us the better results in some scenarios, better than the Facebook profit and the Amazon's algorithm. So we are currently working hardly on that algorithm to implement on the same data sets and to conclude when this algorithm is better than the Facebook and Amazon's algorithms. Thank you very much once again for your time and for your attention. It was my pleasure to be a speaker at this great event.
Thank you, Emir. We enjoyed your lecture, and we are happy to have you. We don't have any questions. If you have something else to say to the audience, you can do it now. Do you have anything you want to tell the audience?
Yes, just that this is really a good event and a good opportunity to share the knowledge between the experts. And thank you once again for the opportunity to share our ideas and to hear good lectures, good presentations. That's definitely a pleasure.
Thank you so much.